Please welcome from CoreOS, Frederic Branczyk.
Hey everybody, I'm Frederic. I'm an engineer at CoreOS. I mainly work on upstream Prometheus, upstream Alert Manager, and Kubernetes itself, and then all the components connecting to the two worlds, basically. So, yeah, why? First of all, I want to explain why Prometheus at CoreOS, and it's basically because, obviously, as Brendan already mentioned this morning, monitoring is a very crucial component of your entire infrastructure, and that's why it's very important for CoreOS to have a working solution. And as part of our commercial offering, we are also automating the monitoring infrastructure, and that's exactly why we're investing into Prometheus. So end-to-end monitoring, what exactly do I mean by that? For the purpose of this talk, I mean that we want to monitor the Kubernetes cluster itself, and then monitor as much as we can about everything that is running within that Kubernetes cluster. So everything we can infer generically about all the workload. And then in addition to that, because we have all of this information, we can build default alerting and dashboarding. And we want to do all of this with the Prometheus Operator, which I also work on. So just as a run of hands, how many people know Prometheus? Okay, that's a good number. How many people of those actually use it? That's pretty good. For everyone else who doesn't know, Prometheus is an open source monitoring solution which was built at SoundCloud in Berlin. And it's heavily inspired by Borgmon. We yesterday heard about Borg at Google, and Borgmon is the monitoring tool for Borg at Google. Because a lot of the people who worked on Borgmon worked at SoundCloud, it's naturally inspired by a lot of the things that Borgmon does. And obviously, one of the most important factors for every open source project is how many stars it has, and we almost have 10,000 stars. So that's obviously a good indicator of why it's good. No, it's not. We will go over why it's good. And Prometheus cares about metrics. That's the important part. We want to, like logging and tracing, for example, are important parts of your monitoring story, but it's not something Prometheus wants to solve. Prometheus is only about metrics. So let's go through a quick example of how Prometheus works. So you have your application, and it's instrumented with Prometheus metrics. And Prometheus, every 15 seconds, for example, goes to your application and grabs those metrics and stores it in its internal time series database. So in this case, at time t0, we have just spun up our application, and there have been no requests against our application yet, so the value is 0. Now, we get some incoming traffic from our users, and as the requests increase, the metrics increase, and the next time Prometheus comes around, it collects that value, whatever it is at that given point in time, and writes it into its time series database. And just to show you that none of Prometheus is magic, how the alerting works is pretty much the exact same way, that every rule evaluation interval, it goes through all the data it has and evaluates the rules for alerting, and whenever it triggers, it sends an alert. Yeah. So how does all of that fit into the entire ecosystem? So this is the overview of all the parts that we view as in Prometheus. So in the middle, we see the actual Prometheus server. And then on the left-hand side, we see the metric sources, or the targets, which is like the application that we just seen. And we discover those through service discovery mechanisms. That can be static discovery. So we say we have these services running on these IP addresses and these ports, or through some more automatic mechanisms, which we'll look into later. And then, as I said, Prometheus does alerting, and whenever it fires an alert, so every 15 seconds, for example, it fires that against the alert manager. And the alert manager then actually sends the notification. So the alert manager is the component that reliably sends those notifications. And that's very important part, and it's very interesting how the alert manager works, but that's another talk. But what we need to know is that the alert manager reliably deduplicates groups and then sends those alerts. But back to the actual metrics. So when we have that metric endpoint that exposes our metrics, that's just a normal HTTP server. And what that looks like is roughly like this, that we have some metric name. In this case, it's HTTP requests total. And then we can add an arbitrary number of labels that describe this and adds basically dimensions to this metric. And then we have the actual metric value. But because Prometheus knows some meta information about this target, it can add this information when it scrapes that. The target itself doesn't actually know this, but Prometheus knows through the discovery mechanism. And that's a very powerful thing for monitoring, because you can then drill down by service, by job, by instance, basically whatever you've added in terms of labels to your target. So as I already mentioned, a target is basically just anything that's an HTTP server and has an endpoint that exposes metrics in this particular format. And while this is just the default, it can be basically everything, but the default is that it's just /metrics under your HTTP server. And those can be discovered with static DNS or basically any service discovery mechanism that you want, but there are a couple built in, and most notably one that's heavily used is the Kubernetes Discovery, and that's what we want to look into more right now. So in Kubernetes, all the workload that we have are pods, right? But we actually have more meta information about those pods. Most commonly, we actually group those pods by services, for example. And then we know that these pods are behind those services, and that gives us crucial information that when we're troubleshooting something, we can tell this is only one pod that has some problem behind our services, or it's all the services, or it's services that are interconnected. So that's very powerful information that we can get just out of using Kubernetes for service discovery. And one other thing is that Kubernetes has these mechanisms of where you basically watch everything that's happening in Kubernetes. So we can automatically reconfigure Prometheus whenever there's any change in your Kubernetes cluster. So let's take an example for that. So we have all our pods. We have 2 front-end pods, a database pod, and 2 API pods. And for those, we have appropriate services. So now we know that that particular pod belongs to that service, and that database pod to that service, and so on. And then Prometheus can just go ahead and say, OK, I want to know all the targets that are behind all of these services. So we don't actually need to find all the individual pods. We just search for all the services and then look which pods are behind those services. So now that we've seen how Prometheus works in general, and how we retrieve metrics, and how we alert, and how we find those targets, what do we actually want to monitor? So we said in the beginning that for end-to-end monitoring, in terms of this presentation, we want to monitor all our Kubernetes components. There's a lot of moving parts in Kubernetes. As of version 1.6, there's the API server, etcd, controller manager, cloud controller manager, scheduler, kubedns. Those are all parts that are part of the master usually. And that's just the master components. And then there are the node components that are running on every individual node of Kubernetes, which is the kubelet and the kube proxy. So those are a lot of moving parts that everything, each individually can break, all or together. But luckily, all of these components are already instrumented with Prometheus metrics. So all we need to do is actually just collect those. However, if we're monitoring all our workloads with Prometheus, we want to monitor the workloads and our cluster in the same way, right? So we don't want to treat Kubernetes in a special way other than our other workloads. And this is where something very powerful comes into play called self-hosted Kubernetes. And this is something that we're driving at CoreOS, and it's basically like a parallel to self-hosted compilers, right? A compiler is often first written in another language, and once the compiler is mature enough, you write this compiler in its own language. And that's basically what we've applied here as well. So we basically bring up a temporary Kubernetes cluster to bootstrap the Kubernetes cluster. And what we end up with at the end is that all the Kubernetes components are running as pods in that very same Kubernetes cluster. It all sounds a bit like chaos, but actually it works really well. And that's exactly how we run Tectonic. And now that we have all those Kubernetes components running in Kubernetes, we can treat them just like any other workload. And that's great because we can just now use the same discovery mechanisms for discovering Kubernetes components as we do for everything else. So it's just like any workload. But other than that, we can't infer anything else regarding our workload, right? For the Kubernetes components, we know how they work. They work the same for all other Kubernetes clusters out there. The scheduler does the same thing. The kubelet does the same thing. So we can monitor more exact things. But for the generic workload that we're running on top of it, we can't. However, there are some things that are common for all workloads. So all workloads use CPU. All workloads use memory. Not all, but probably all will use network, and most of them will use some disk as well. So those are all metrics and information that we can gather for these workloads as well, and potentially alert on or dashboard. And in addition to that, because we're using Kubernetes, we have a bunch of meta information that we can add to all of those targets. So for example, if we want to join different metrics together, we can do that based on information that we have from Kubernetes because they have particular labels in common or things like that. But once again, custom metrics by definition are not generic, so that's not something we can do generically. So what kind of information can we get in terms of workload? The node exporter from the Prometheus project gives us lots of metrics about the particular node. So incoming traffic, disk, memory, CPU usage, all those kind of things on a per node basis. Then cAdvisor basically does the same thing, but on a container basis. And then kube-state-metrics is an interesting one because it basically it's an exporter to export state that is within Kubernetes. So for example, your deployments have an expected number of replicas, and you can alert on whether that number of replicas is actually the same as it's supposed to be. So basically what kube-state-metrics does here is it takes all the API objects from Kubernetes and converts those to the Prometheus metrics format. And that would look something like this, for example. So we have a deployment object that has replicas 5, and the available here in the status is the important part, basically. The available replicas are 5 as well, and the status replicas are 5 as well. And so what the available replicas would be converted to here is something like this. So it would be kube, just as a namespace, deployment status replicas available, and then the deployment name, and then which namespace it is, and then the actual value. And that's really powerful because a lot of people, when they start using Kubernetes, they debug their system by using kubectl, right? And this is basically the automated way of doing this. So any information that you were previously manually trying to figure out using kubectl, you can now use in an automated way. Okay, so that's all good. We know how Prometheus works. We know how alerting works. We know what to monitor. Now let's actually configure this. As it turns out, we have lots of different components that we want to monitor here. And I couldn't even fit all of those, even though I'm using like 0.6 point font size here. I couldn't even fit all of those on one slide. And that's because it gets really complicated because the Prometheus configuration language is agnostic to the platform it's going to run on. Prometheus can do all kinds of environments. It can do Mesos, it can do Kubernetes, it can do console service discovery, all kinds of things. And that makes it very good for a variety of applications. However, it makes the configuration a lot harder. And then there are a couple of things. If you've used Prometheus, you've probably bumped into relabeling, which is like the dark magic under Prometheus. Yeah. And yeah, alerting and the alert manager are different problems, but they're also pretty hard. But because we know our environment that we're going to be running in, we can abstract all of these things away that are not important for us. And yeah, but the thing is that when we actually do write these configurations, they get really, really long. So I did this on an example basis, and I ended up with a configuration of 328 lines. That's basically not something that anyone wants to maintain. So I just wanted to exemplary show what that would actually look like. This is the first slide of configuration. Second slide, yeah. So that was only 72 lines of the 300, more than 300 lines of configuration. So that's not really a manageable thing to do, right? Whereas all we want to really do is monitor those services that we have in Kubernetes that are some pods, and that there are some pods behind that. So that's exactly why at CoreOS we built the Prometheus Operator. So that because we know the underlying platform that we're going to have, we know that we're going to be using Kubernetes, we can write really nice abstractions, and you actually won't have to learn all of those configuration paradigms that are really complex for Prometheus at all anymore. Instead, you can just use all the paradigms that you're used to from Kubernetes to configure your monitoring tool. So what that ends up with is that we, as Prometheus maintainers and contributors, have this knowledge of how to operate Prometheus and can put that into code. And that's exactly what this is. And we can write Kubernetes native configuration for this, and we can handle upgrades for you, and a lot of other functionality. So what does that look like in reality? So basically, we just looked at how do people, or how do other Kubernetes objects work, and basically everything in Kubernetes is based on labels and label selectors. So that's exactly what we did. We wrote a third-party resource, which is called Service Monitor, and basically all it does is that it has a selector which selects services. That's exactly what we wanted to do. And this will generate the actual configuration that is underlying for Prometheus, and will configure Prometheus that way. And then, in addition to that, we wrote the Prometheus TPR, which does all the nitty-gritty things of operating Prometheus itself. Because Prometheus is a stateful application, right? That's kind of hard to do, but because we know all of these details as maintainers and longtime users of Prometheus, how to do that. But there are still a lot of moving parts, right? Even if we have all of these nice abstractions now, we still wanted to use all of this for end-to-end monitoring, right? And that's where another project that uses the Prometheus operator comes into play, which we call kube-prometheus. And this is basically a collection of manifests and assets that does all of this. So you can basically just clone this, run a single script against your cluster, and it will install everything into a monitoring namespace, and you'll be able to monitor your Kubernetes cluster. And it ships dashboards, it ships alerting rules, and it ships the alert manager. And what's great about this is that all of this is open source, and we can all work together on this. And basically, it's just like Brian said yesterday morning, because we can all work together on this, because this is all DIY, we can all work together and come up with the best alerting rules because we're all running Kubernetes clusters, right? We all run into the same problems. We can write runbooks, again, for how to solve all of these problems, and that's really great. So yes, kube-prometheus, look it up, but we'll also run a quick demo of that. So I have a Minikube cluster here, and these are the components that are running in it. So we can see, I'll make this a bit bigger. We have a cluster of alert manager running here. We have Grafana running. We have kube-state-metrics running. We have the node exporter running. We have 2 instances of Prometheus running, and the Prometheus Operator, which is managing all of these components. And when we then switch to the Prometheus UI, we can see that it actually discovered all of these components. It's scraping the alert manager, the API server, controller manager, all of the different components that we were looking at earlier. And this works in a generic way, as in once you have a self-hosted Kubernetes cluster, this will pretty much work one click for you. And as I said, we also have pre-built alerting. So for a lot of the Kubernetes components, we have pre-built alerts. So when anything goes wrong, you automatically get notified. And for this is the next thing is a glimpse into the future. This is something we're working on right now, where in Prometheus alerting rules, you can basically add these annotations. And we want to start, whenever we write all of these alerting rules, we sort of know what to look for, how to solve these problems, right? Does anyone know what you should do when your scheduler dies? Because when your scheduler dies, nothing can be scheduled anymore, right? You can't schedule a new scheduler. So that's one of those things that happens pretty often, actually, or fairly often. People run into this. And so we documented how to troubleshoot this. And this is really, really great because we all run into these same problems, and we can all write these alerting rules that then have the solutions right in them. So we just need to go there and see how we could recover the scheduler in a case like that. Okay, that's, no. Yes, so that was alerting, but I said we also have pre-built dashboards for all of these things. So we can see we have all our pods, for example, and we have some nice graphs for all of the network usage, CPU usage, memory usage, and all of those things. And we can even do that associated with deployments. And a lot of these things have actually already been contributed by the community. And that's really great because everyone needs all of those things, right? And they're common to all Kubernetes clusters. Okay. And the last thing I want to mention is, so again, coming back to the beginning of my presentation, how does all of this fit into CoreOS? So basically, everything I've shown you today is something that is already or will go into our product. In addition to having all of these alerting rules and dashboards and everything, all of these things will be self-upgrading. And whenever there's anything new, like we've heard of some incident that has happened and we know how to solve it, we'll push upgrades to your cluster, and all of these things will work by itself. And it, of course, then also updates all the individual components. So you always are running on latest Prometheus, latest node exporter, and all of those components. Okay. Yeah, actually, that doesn't work. So with that, thanks for your attention. And if there are any questions, I'll be happy to answer them.
Thanks for the talk. We are actually using Prometheus in our environment to monitor our clusters, but one difficulty we are facing is we have the services deployed across clusters. So how do you, first of all, does it have support for cluster federation? And is it possible to have a more higher level dashboard that will give us a more holistic view of the service across the clusters?
Yeah, so yes, Prometheus does support federation. It works very similar as a parallel to Kubernetes federation, whereas you just point those at your other Prometheus instances, and it takes those metrics from there that you can select which ones you want, and yeah, it just fans all of those in, and then you can do exactly what you just said. So basically, all information that you can collect, you can dashboard and alert on. So that's totally something you could build.
Okay, but we actually are not using federation. So is there a interim solution?
Well, you mean you're not on Kubernetes federation, or?
Yeah.
That doesn't matter, actually. So Prometheus is completely agnostic to Kubernetes, right? It has integration into Kubernetes, but you can do Prometheus federation without using Kubernetes federation. Yeah, absolutely.
Thanks.
Okay, like there. Just the mic.
Who had the question? There you go.
What is the permanent storage used for storing the metrics in the Prometheus?
Can you repeat that?
The data storage for database storage for the metrics.
Okay, so that's you mean the actual time series database. That's completely custom to Prometheus. Actually, we're working on rebuilding that storage right now. My colleague Fabian has a great talk on that, and we're going to be releasing that with Prometheus 2.0, which is something that Brendan showed this morning, which is this is all open source, and it's actually a separate library. So if you wanted to, you could even take that time series database and implement it in your own tool. Of course, that implementation is highly specific to how Prometheus is used, but if you use a similar mechanism where things have labels and values, basically, then it would work for you. Okay, there's one more question in the back.
Does the Prometheus operator implement HA via multiple Prometheus instances or another approach?
Yeah, so for both, I didn't show the alert manager part, but for both alert manager and for Prometheus, you can certainly do HA. Basically, for Prometheus, how HA works is that you just run a second instance with the same configuration, because that way it just scrapes the same targets, right? And for the alert manager, it's a bit more complicated, but that's also supported. Okay, there's one more question.
Yeah, so for someone who's using a StatsD solution right now, without having to retool all of our applications, what's the easiest way to convert over to?
Okay, that's a great question. Actually, there are, for a number of other monitoring tools out there, there are bridges to basically export all the information that are in your current monitoring system and fan them into Prometheus. So, of course, you won't be able to switch all your applications that are already instrumented at once to be instrumented with Prometheus. That's not feasible, but absolutely that's a concern that we've already addressed, and there are those implementations of bridges from StatsD, Graphite, and a couple more I can't recall right now, but yeah, that totally exists. Okay, thank you.
Lights and music.